Okay, so in this video I'm going to have a look at the Leaving Certificate Higher Level Maths Paper 1 for 2018, and I'm going to have a look at question 8. So question 8, part A, we're given a graph here and it's a symmetric function. F of x is equal to 1 over square root 2 pi e to the power of minus a half x squared. So we have 3 points on this symmetrical function here. We have B, C and A. So first part here, part A, says find the coordinates of A, the point where the graph intersects the y-axis. Give your answer in terms of pi. So we know that on the y-axis all points have an x-coordinate of 0. So all we've got to do is just work this out. 2 pi e to the power minus a half. And we just put a 0 in here for x. When you work this out, well, e to the power minus a half times 0 squared, this power is just going to be 0. E to the power of 0 is 1, so we just end up with 1 over square root of 2 pi here. So our point A is 0, 1 over the square root of 2 pi. And that's it. That's our point A. Okay, so let's have a look at part B here. The coordinates of B are minus 1, 1 over the square root of 2 pi e. Find the area of the shaded rectangle in the diagram above. Give your answer correct to 3 decimal places. So we've got to find the area of this shaded region here, this rectangle. So the area of a rectangle is length times width. So the length we know is, well, B has coordinates minus 1, so C must have x coordinate minus 1, so C must have an x coordinate of plus 1. So the length along here is 2. The y coordinate of B is just going to give us the width. So that's all we got to do really. So we know that the area is just going to be length times width. So the length is 2 units and the width is our y coordinate here, 1 over the square root of 2 pi times e. Now you can just, we need to give our answer correct to 3 decimal places, so you can just do this on your calculators, and when you multiply all of this out you get 0.484 units squared, so whatever the units are. So this is to 3 decimal places. Okay, part C then, use calculus to show that f of x is decreasing at C. So decreasing at C. So C here, we can see it is decreasing here. So how do we do that? Well, what we're going to do is we're going to differentiate this function, which will give us the slope of any tangent along the curve here. If we know the x coordinate at C is 1, so all we've got to do is put 1 into that differentiated function. If we get a negative number, it means the slope here, the slope of the tangent will be negative, therefore the function is decreasing at C. So that's our strategy anyway. So we're going to write down our function, which is, let's see, f of x. F of x is equal to 1 over the square root of 2 pi e to the power of minus a half x squared. This is our function. We want to differentiate this. So, well, if you differentiate e to the power of x, you get e to the power of x. So that's what we've got here. We've got an e to the power of, well, actually some function of x. So we're going to have to use the chain rule here. It's not e to the power of x, it's e to the power of some function of x. So when we differentiate it, we get 1 over square root pi e to the power of minus a half x squared anyway. Now we've also got to differentiate this function of x up here. If you differentiate minus a half x squared with respect to x, well, take the 2, bring it down here, multiply minus a half by 2, you get minus 1, and reduce the power here by 1, so you just end up with x to the power of 1. So we're just multiplying this by minus x. And that's really it. What were we asked to do here? Use calculus to show that f of x is decreasing. Okay, so we've differentiated our function here, and now we've got to put in our x coordinate. Well, at C our x coordinate is 1, so we just stick that in here and we get e to the power minus a half x squared here. Sorry, that's going to be, we got to put in our we got to put in our 1 here. So we got to put in 1 here and square it, and then we got to multiply all of this then by -1. Okay, so really all of this can be just done on your calculator. Really we've just ended up with minus e to the power of minus a half over square root 2 pi. This minus 1, I've just brought that over here. This 1 squared is just 1, so that disappears. So you just end up with minus a half here. Now if you work that out, again you can just do that on your calculators, you get minus 0.24197 and so on. So the slope of the tangent at C is negative. So the slope of the tangent at the point x is equal to 1 is negative. So you can say that slope at, or the slope of the tangent, slope of the tangent at x is equal to 1, or C, I think, wasn't it? C, yeah. Or at C is negative. Therefore, the function is decreasing at C. Okay, so that's it. Now part D then, show that the graph of f of x has a point of inflection at B. A point of inflection at B. So if we look at B here on our graph, we have apparently a point of inflection here. So points of inflection are found by differentiating the function twice and letting that second differential equal to 0. So what we're going to do is going to differentiate this function a second time. We can show that that's equal to 0 by putting in the x coordinate here, which is -1, and we should end up with 0. So let's do that. So we've got to differentiate this function a second time. Now the first differential that we got was, let me just see here, we got 1 over the square root of 2 pi e to the power of minus a half x squared, and then we had a minus x here as well. This is what we got when we differentiated the function the first time. So let's just differentiate this again. So we've got to differentiate this a second time. Now in this particular case we have a product here, so we have to use the product rule. Here we have a function with an x in it. Here we have a function with an x in it. They're both multiplied, so we got to use the product rule. So the product rule is u dv dx plus v du dx, and that's our dy dx. Now in this particular case I'm going to take this part here as u, and I'm going to take this part here as v, and I'm going to just write it out then. Okay, so we've got to write out u first. So u is just e to the power of minus a half x squared over square root 2 pi. That's my u part here. We've got to differentiate v, so dv dx. So v is minus x. If I differentiate minus x, I'll just get -1. So I'm going to be multiplying this by -1. So what I'm going to do is just put the minus here. There's my -1, multiplied by all this. Plus, now v, got to write down v. Well, v is minus x. So the v minus x will go here. So what I'm going to do is actually just change that to a minus and put the x here. Now I've got to differentiate u. So I've got to differentiate all of this. Now we've done that already, and we got, let's see, we ended up with e to the power of minus a half x squared over square root 2 pi times minus x. Okay, so all of this here is what we get when we differentiate the particular function f twice. Now let me just see if I can simplify all of this. Here I've got minus e to the power of minus a half x squared all over square root 2 pi. Now with this part here I've got this x multiplied by this multiplied by minus x here. So what I'm going to do is multiply this minus times plus times minus. That'll give me a plus. I've got an x times an x, which is x squared. And here I've got e to the power of minus a half x squared all over the square root of 2 pi. Okay, so what we can do now is we know that b has an x coordinate of minus 1. So at x is equal to minus 1, f double dash x here, our second differential, will give us minus e to the power of minus a half times minus 1 squared. I'm putting in minus 1 instead of x, all over the square root of 2 pi, plus, here I've got minus 1 squared. Here I've got e to the power of minus a half. Again, I've got minus 1 squared here. And I have square root of 2 pi on the bottom here. Now, when I simplify all of this, let's see what we get here. Well, I get minus e to the power of minus a half, because minus 1 squared is 1. 1 times half is a half, over square root 2 pi. Here I'll have plus. Minus 1 squared is 1. So here I'll end up with e to the power of minus a half here on top, and on the bottom square root of 2 pi. Well, if you look at these two, you have minus all of this plus all the same thing. You have minus e to the power of minus half over square root 2 pi plus e to the power of minus half over square root 2 pi. That's just equal to 0. So at the point P, or sorry, B, I think it was, at the point B, f of x differentiated twice is equal to 0. Therefore, we have a point of inflection at B. Okay, another way of looking at this, actually, there is another way of doing it. I'll just run through it. We got a second differential here. Our second differential was, let's see, minus e to the power of minus a half x squared over the square root of 2 pi plus, over here we had an x squared, e to the power of minus a half x squared over square root 2 pi. So this was our second differential. Now what we can do here is just work backwards just to see, do we get a point of inflection at the point x is equal to minus 1. So if we can work out what x is when all of this is equal to 0. So let's have a look. I'm just going to try simplifying this a little bit first, factorizing it a little bit. You can see that we have some common factors with these two terms. We have an e to the power of minus a half x squared here over square root 2 pi. That's in both of these terms. Now if I look at this, so I'll just put the plus one first. I'll just be left with x squared here. There's an x squared here multiplied by this part here, which I've taken outside the bracket. Here I'll just end up with minus 1. Now if this is to be, this here is what I get when I simplify this. This has to be equal to 0 to work out our point of inflection. So let's see if we can work out what x would be. Now in order for this multiplied by this to be equal to 0, that would mean then that e to the power of minus a half x squared over square root 2 pi is equal to 0, or over here we have x squared minus 1 should be equal to 0. So let's work this out. If we just look at this part here, for this here, this fraction to be equal to 0, the numerator has to be equal to 0. In other words, e to the power of minus a half x squared must be equal to 0. But that's not possible. It's not possible to raise e to the power of anything to get a 0 here. So this can't be true. So we've got to concentrate on this part over here. Now if you look at this, really here we've got an x squared minus a 1 squared, if you like. That is the difference of two squares, so that will give us x plus 1 times x minus 1 is equal to 0. That will give us x is equal to minus 1 or x is equal to plus 1. So we can see that we did get an x is equal to minus 1, which is the x coordinate of b. There does happen to be a point of inflection on the other side as well. I think it was point C, but we were asked in this particular question to show that b, the point b, is at a point of inflection. So we did get minus 1 as an x coordinate for our point of inflection. Okay, so that's it for this question.